All right, so today we're looking at perfect square trinomials, which is a way to factor polynomials. So let's look at this equation up here, which is a squared plus 2ab plus b squared. And that equals a plus b times a plus b, or a plus b squared. Now if we have a squared minus 2ab plus b squared, that gives us a minus b times a minus b, or a minus b squared. These products are called perfect square trinomials because they're the squares of binomials. This pattern also helps us factor perfect square trinomials. So first we're trying to decide if this first 4y squared plus 12y plus 9 is a perfect square trinomial. So we need to ask ourselves 3 questions. Is the first term a perfect square? That's 4, so the answer is yes. Is the last term a perfect square? We're looking at 9, and that's also a yes. The third question we have to ask ourselves is the middle term equal to, and then we're taking 2, right? So 2 times 2y times 3. Because we're taking the 2 from our 4, the y from our 4, because those are the 2 things we're squaring, and then the 3 from our 9, which is that squared. So 2 times 2y times 3, which is in fact 12y. Since all of these terms all of these questions are confirmed, then yes, it is a perfect square trinomial. Now let's look at this one. We have 9 and we have 4. Both of those are perfect squares, the first term and the last term. Then we're looking at the middle term. So is the middle term equal to 3 and x, because that's what we're squaring here, and 2. So 3 times 2, x, and it's positive 6x. So since that is not satisfy the third condition of the perfect square trinomial, then the answer to that is going to be no. It's not a perfect square trinomial. The other thing we're going to look at is the square root property when looking at perfect squares. The square root property tells us that any number where n is greater than 0, n being this 25 and this 81 over here, if x squared equals that number, then we can just take the square root of it. So we're going to go ahead and we're going to take x equals the positive or negative square root of 25. So here x is going to equal positive or negative 5. Here we do the same thing, but we're keeping y minus 6. So y minus 6 equals the positive or negative square root of 81. That means y minus 6 equals positive or negative 9. We're going to have to solve that here. Y minus 6 equals 9. Y minus 6 equals negative 9. So y equals 15. And y equals negative 3. So those would be our 2 roots, 15, negative 3. So perfect squares are looking for those 3 conditions being satisfied for perfect square trinomials. And then the square root property is just switching the squared part of our x or of our variable and giving the square root on the other side.